Now we're going to look at graphing these parabolas. So I'm going to try to make this as short as possible, but with these graphing problems, I like to go a little slower just so you can understand them. So the first thing we're going to do is write everything in standard form. You're not going to have to worry about that, but we do want to determine the type of parabola. So we want to know if it's vertical or horizontal, because that will just help us a lot as we graph these. And I'll show you all the information it tells you. Then we're going to figure out our vertex, and we're going to graph that, which that comes from h and k, like I said, from our equations. So we've got minus h here. So when we pull that out for our vertex, we just have to flip that sign. And then we've got minus k here. So when we pull it out, we have to flip the sign there. And then we'll solve for p, and that'll determine the direction of the opening for our parabola. And then it says to use the absolute value of p to graph the focus into Directrix. We do that, but I don't know. That's kind of an odd way of putting it. That can confuse some people. So I'll just show you. I'll basically explain to you what that's going to mean. And I went over it a little bit in the last video, but I think it'll make sense when we actually graph these. So let's look at some problems. So here's what I would do first. First, we want to know what type of parabola we have. So if x is leading, remember that we established that x lead on a parabola means that we have a vertical one. So I would just write that x is telling me that I have a vertical, and I'm going to abbreviate it just to VERT period. That just helps us with a couple different things in a second. So then what I would do after that is establish my center. And my center comes from x and y. So if x and y don't have parentheses, that just means my vertex, which I think I may have just said the center, but that means my vertex is just 0, 0. So if you see x or y by itself with no parentheses, that means that the x or y coordinate for the vertex is going to be 0. So here my vertex is 0, 0. Now I'm going to tell you something that you can already do with the center or with the vertex, so we can graph that. Let me zoom in. So we can graph that. And then the type of parabola actually tells us what direction or what type of axis of symmetry we have. Because if this is a vertical parabola, it's going to either open up or it's going to open down. That means that my axis of symmetry is going to be vertical as well. So that vertical line or vertical axis of symmetry will go straight through that center. And so that already gives you an indication of what your axis of symmetry is, because over here we have to write it. So an easy way to do this is once you figure out what type of parabola we have, like right here you have a vertical one, just make it a vertical line, your axis of symmetry. Make that axis of symmetry a vertical line that goes exactly through the center or the vertex. So the equation for this line, since it's vertical, would be x is equal to 0. So that's an easy way to go ahead and knock out that part. All right, now we've got to figure out what P is, because we've already graphed our vertex. It didn't tell us to, but the axis of symmetry helps us, which I guess it told us in the directions. But then we need to solve for P. Here's how you're going to do that for every single one. So on the right side of your equation, we have a coefficient here, -8. You're going to bring that -8 down and set it equal to 4p. Because essentially, we're looking at this portion of our equation, and we just need to see what p is if 4p is equal to 8. So that's why you set whatever that coefficient is equal to 4p. And then we will solve. So if we solve for p here, we would get, let's see, we would have to just divide by 4 on each side. So we would get p is equal to -2. Now, the reason that is important is because now that tells us which direction our parabola will open up in. Because if this is a vertical parabola and p is equal to -2, and we go back to this portion here, that tells us that p is less than 0. So this parabola is going to open down. So when we graph this, it should open down. Now this is where this is where I don't really like how we're given the absolute value of P. I get what they're saying, but what I would do is, because next, if you look over here, we need to focus in the directrix. So if we're looking at a vertical parabola and it's opening up down, that means we're going to use P to tell us our focus and our directrix, which we'll do that for every one. But an easy way to try to look at this is, if this is vertical, that means our directrix is moving up or down. So, or our focus is moving up or down. And since this is a -2, it's moving down. So if we want to plot our focus, we're going to start at our center and just count down 2. So that would be right here. So hopefully that makes sense. And the more we do these, hopefully it'll make sense. That's why I'm going to leave it as -2, because that kind of is an indicator that you're going down if we're looking at the y-axis. So I'm going to leave it as -2, not do the absolute value of P. So hopefully that's less confusing. So that point, that red point there, would be my focus, because it's 2 units away from the center or from the vertex, and we're going down 2 units. Since this is a vertical parabola, we're dealing with the y-axis. So we're going, and P was equal to -2, so we're going -2, so we're going down 2. So that point would be at 0, -2 for our focus. And then the directrix is just 2 units in the opposite direction. So if we went down 2 for our focus, now we're going to start at our center or our vertex. I don't know why I call it the center, but we're going to start at our vertex and we're going to go up 2. So it would be right here. And that would be our directrix, which our directrix is always a line, not just a point. So for this part, you'll actually make the equation of a line. And if you remember, our directrix is always perpendicular to our axis of symmetry. So if our axis of symmetry is this vertical line, then our directrix would be a horizontal line going through that point that is 2 units above the vertex. Or it's just in the opposite direction of the focus. So that line right there is our directrix. So that line would be y is equal to 2, because it goes through 2 on the y-axis. So that would be y is equal to 2. So now the last thing we have to do is just really sketch our parabola. We're just going to sketch these. They don't have to be exact, but we can make them like relatively exact. So our parabola should go through this point here, which is the vertex. That's like our turning point. And it should open up downward. So we can just make our graph or our parabola look like that. That may not be exact, but it should be. I mean, it is what it is. If it has anything weird going on here, we would probably need more information to figure that out. Like if it were shrinking or compressing, or shrinking or stretching. But we don't have any of that going on, and we're not going to deal with that. So just like make your parabola open up or down or left or right. Other than that, as long as it goes through that vertex, I don't really care if it's exact. Just try to make it, I guess, equidistant on both sides. But other than that, there's not too much there to worry about. All right, so we'll look at another problem. Now we have y squared is equal to 6x. So we are going to establish, first of all, what type of parabola we have. And since y is first, if we're reading this left to right, that means that we have a horizontal parabola. Because if you remember, we established up here that, let's see, y, oh, I guess I already erased it. So y leads with a horizontal parabola. So that just tells us that we should have a parabola that opens up on the left or the right. But we'll figure all that out. So then we've got to find our vertex. We need to graph our vertex first. So our vertex is going to come from the parentheses that are with y and x. We don't have parentheses here, so that means my vertex is 0 and 0. Now, we can figure out our axis of symmetry, because if our vertex is here and this is a horizontal parabola, we need a horizontal axis of symmetry. So that axis of symmetry is going to go horizontally through our vertex. So that equation for that line would be y is equal to 0, because horizontal lines are y is equal to. All right, so we've gotten our first two parts knocked out. Now we're going to have to find the focus and the directrix, and that comes from P. So in order to find P, we take this coefficient 6. So that's going to always be on the right side of your equation. So we're going to take that coefficient 6 and set it equal to 4P. And then we'll solve for P. So we would divide by 4 on each side, which is going to give us 6 over 4, which is 3 over 2. So here's what I would do if I were you. I would say P is equal to 3 over 2 or 1.5. That way you have the decimal for graphing purposes. Because to me, it's easier to graph decimals than it is fractions. But if you want to graph a decimal or a fraction, and you can do those better, then do it however you want to do it. All right, so now we know P, and P was positive here. So that tells us something about the direction of our horizontal parabola. Because if our parabola is horizontal, it's going to open up right and left. And if P is greater than 1 or greater than 0, then it opens up right. So this is going to open up right. And since that P is positive, that means when we go to count from our center for our focus, we're going to count right for our focus and left for our directrix. Because if we're on the x-axis, right and left, well, right would be positive, left would be negative. That's why I'm not going to do the absolute value stuff that they were talking about in the notes. I'm just going to let you have a little cheat code here, I guess, that if this number is positive, that means you're moving right on the x-axis. And if it were positive and we were looking at the y-axis, it would move up and down, or it would move up. So I'm going to leave it like that just so it's not confusing. All right, so now just like I said, if we want to know the focus, we're going to start at the center and we're going to count P units to the right, since this is opening up to the right, since our parabola is. So we're going to take, and we could also say that, like I said, since we're on the x-axis, that 3 over 2 or 1.5 is positive, so we're moving right because all my positive numbers move right. So I'm going to start at the center and move over 1.5, which is right about there. And that point, that ordered pair, is going to be my focus. So that ordered pair would be at 1.50, or you could say 3 over 2. But I'm going to leave it as a decimal because I like decimals better. Now my directrix is just 1.5 units in the opposite direction. So if we went right for the focus, we're going to go left 1.5 units, or we're going to go minus 1.5 units. So that would be 1, that would be right here. So that is my directrix, and my directrix is going to have a line through it that is perpendicular to my axis of symmetry. So if my axis of symmetry is horizontal, my directrix would be a dotted line that is vertical. And the equation for that would be x is equal to negative 1.5, because that's where it intersects, or that's where it goes through the x-axis. So now that's everything we need, at least for the information. And now we can approximate where this parabola would be. We established that it opened up on the right, so it's going to open up like this. Something like that. And just make sure it goes through this vertex. All right. Now we'll do 3 and 4. So number 3. Now we've got parentheses thrown in here, but that's not going to change a lot for us. Or I guess it'll change a lot, but it won't be too difficult. So the first thing we need to do is establish the type of parabola. So since we see, if we were reading this left to right, we see y comes first. So a y lead for a parabola means that this is horizontal. So we know we're going to have a horizontal parabola. Now, we're going to find the vertex. So the vertex comes from what is in parentheses here with y and here with x. Just make sure that you notice that x is presented, or y is presented to us first. So a lot of people would say that this center or this vertex would be 2, 3, but that's not true because x has -3 with it. So that means when we pull it out for our vertex, it's going to be a +3, and that is our x-coordinate for our vertex. So make sure that you watch yourself on how they're presented to you, because a lot of people would just read this left to right and say, okay, my vertex is 2, 3, we're done. But that's not true. You just got to watch it because they'll change the order on you. So then our center, or our, I don't know why I always call it the center, but the vertex comes from h and k, which we already established that h was 3, and then k is a -2 in the parentheses with y. So when we pull it out for our vertex, we just have to flip that sign. So our vertex here is 3, 2. So we're going to plot that. So 1, 2, 3, 1, 2. That would be right here. Now, I told you before, we can actually find our axis of symmetry now, because if this is a horizontal parabola, we need a horizontal axis of symmetry. And that horizontal axis of symmetry is going to go right through our vertex, and it's going to be a horizontal line that looks just like that. So that equation for that line is going to be our axis of symmetry. So that equation for our line would be y is equal to 2, because that's where it intersects the y-axis. All right, so now we need the focus and the directrix, and to find that, we need to know what P is. So we're going to take this coefficient here that's not in parentheses, that's on the right side of my equation, and we're going to set that equal to P, or 4P. So we're going to have -4 is equal to 4P, and then we'll solve for P. So that would give me P is equal to -1. And if we have a horizontal parabola, if P is less than 0, that means that this parabola is going to open up left. And that also tells me where my focus is. So my focus is going to be -1 unit away from the center. And if my parabola here is horizontal, that means we're going to move our focus and our directrix on the x-axis. So -1 unit on the x-axis would go to the left 1 from the center, which would put me right here. So I don't know why that just did that. That was pretty wild. All right. So it would be right there. So that is our focus. And then our directrix is actually going, well, first let's write down that ordered pair. So that would be 2, 2. I think, yeah. So the focus would be at that ordered pair 2, 2. All right, then our directrix is going to be 1 unit, but now it's going to be in the opposite direction. So now we're going to go +1 unit, which is actually, if we're moving on the x-axis, that means we're going right 1 unit. So that would be right here. And then that directrix is going to have that's the point that our line's going to go through. So our directrix is a dotted line, and it's going to be perpendicular to our axis of symmetry. So if our axis of symmetry is horizontal, that means that directrix is going to be vertical. And the equation for that line, let's see, it intersects right here on the x-axis. So that would be x is equal to what? 4? Yeah. X equals 4. And now we have everything we need. We just have to sketch this parabola. So our parabola is going to go through this purple point here, which is the vertex, and it's going to open up left. So it's just going to look something like this, which I guess it needs to be connected. Yeah. So it's just going to look something like that. It doesn't have to be exact. If you just do it like I did it there, you would be fine. All right, then the last one. We've got x plus 1 squared equal to 14 times y plus 2. So we need to find the type of parabola this is first. So x is leading, so that means that this is going to be a vertical one, which that's a little counterintuitive. But if I were you, I would just keep checking back with the top part we went over. Vertical is going to be x lead, horizontal y lead. That way you don't have to, or that way you can kind of check yourself on the fly. All right, so this is going to be vertical. Now we need to know our vertex. A vertex comes from our parentheses with x and y. So in parentheses, we have a plus 1 for the x, or that's with x. So that means the x coordinate for my vertex will be minus 1. We have to flip that sign. And then the y parentheses, or the parentheses with y in it, has a plus 2, which means our y coordinate for our vertex is going to be minus 2. So we can plot that. So negative 1, 2 would be right here. And we also can figure out our axis of symmetry, because if this is a vertical parabola, then that means we need a vertical axis of symmetry. And that axis of symmetry will go directly through our vertex, and it would just be a vertical line, which that was pretty bad. That one's pretty bad too. But you get the point. So that axis of symmetry would have the equation, since this goes through the x-axis here, our equation would be x is equal to negative 1. Now we need to know our focus and directrix, and for that we need P. So we're going to take our coefficient, whatever that is. It shouldn't be in parentheses. It should just be on the right side of your equation. And it's just multiplied by your y, or it's outside of the parentheses on the right side. So we're going to take that 14 and set it equal to 4p, and then solve for p. So to solve this, we'll divide by 4. So 14 over 4 will be equal to p. So p would equal 7 over 2. Or I would say it as a decimal, which 7 over 2 is, I actually don't know that off the top of my head. I think it's like 3 point something. Yeah, 3.5. So I would write it as a decimal too. So now that tells us what direction our parabola is going to open up in. Because if this is vertical and p is greater than 0, which 3.5 is greater than 0, then that means this is going to open up. So then that means that if p is positive and we're looking at a vertical parabola, we're looking on the y-axis. So if we want to find the focus, we're going to go positive 3.5 units away from the center. And anything that's positive on the y-axis is up, or it moves up. So we're going to go up 3.5 units. So 1, 2, 3.5 would be right about there. So that's where our focus would be. So that equation would be, or that ordered pair would be negative 1. And then it would go up, what, 1.5 maybe? Yeah. So it would go up 1.5. And then our directrix is just going to go 3.5 units, but it's going to go in the opposite direction. So now it's going to go down, or we're going to subtract 3.5 units. And if we're doing minus or subtraction or a negative number on the y-axis, we move down for that. So we're going to go to the center and go down 1, 2, 3.5 would be right about there. So then the ordered pair for that would be, let's see, negative 1, 1, 2, 3, 4, 5, 5.5. So it'd be negative 1. Or actually, I told you wrong. We don't need this ordered pair for our directrix. We just need the line. So the line for this will be perpendicular, for the directrix will be perpendicular to our axis of symmetry. So if our axis of symmetry is vertical, we need a horizontal line. and that horizontal line would go through 5.5 or negative 5.5. So it'd be y is equal to negative 5.5. Yeah, I almost screwed that up. So yeah, your directrix is going to be an equation for a line, or it'll be y is equal to or x is equal to. And then your focus and vertex will be ordered pairs. But then we have everything we need. We already kind of did, but now we can just graph this. So if our parabola opens up, we need to make sure it goes through our vertex. So it's going to open up this way. And that is 1 through 4 from the notes, and then we'll look at some homework problems in class.